So this is my simple setup. Basically, output goes from ET200 card to relay, and from relay goes like feedback to PLC. Okay, so when I press this button, output goes to relay, activates the coil, and then input goes to PLC, right? So everything is working. But I started to investigate what kind of signal comes out from relay. So I'm using my scope. What I think is happening: relay coil activated, and normally closed contact on relay changes state to normally open, and it basically do a connection like that, and we have signal. But when I watch this signal in the scope, what I think is happening: when relay is activated, relay bounces 7 times. That could be an issue, because you press push button to activate relay, but actually this relay gives not one signal to PLC, but 7 signals. Let's investigate this. Okay, so right now I will press push button. I have my scope set to roll mode and in single, and basically I'm triggering positive edge. So as you can see signal, and you think, okay, this is perfectly normal signal. This is signal from relay output contacts. So if I change my time base, look what I have at the start of the signal. So yeah, we have these bounces. We can use cursors. And it's very hard to do that on camera, but this first bounce took 13.8 microsecond. Second bounce 12.2 microseconds. Third bounce longer, 33.8 microseconds. Fourth bounce 18 microseconds. Fifth bounce 48.4 microseconds. And don't get me wrong, this is used relay, this is not new, but I use it new relay. This is Omron Relay, and I have same readings. And at the end of the contact it's very clean. It opens quickly. When you release the button, there is no issue. It goes straight down. So right now I will wire solid state relay. Also it is used also from Omron company, and we will see trace on scope. Okay, so right now I wired solid state relay. Okay, so we capture that. I'm changing time base, and yeah, I don't see bounces. I see it overshoot a little bit. Okay, So it goes to 23.6 and then drops to actually 20.7. So I don't see anything bouncing. And let's scroll to see the end of the signal. Yeah, it kind of ramps down. So it's weird because mechanical Omron relay just straight cut down, and what I finding with this solid state Omron relay, it goes kind of ramp down, so it takes 41.2 microseconds to ramp down, but there is no bounces. So right now I will jump to TIA portal and investigate if this is actually a problem. So here I have just a simple logic. I take start push button input and I take positive edge. I use counter, count up logic, same. I take feedback from relay output when it's activated, and also use count up counter. So in the traces, I right now pressing this start button. Okay, so I stopped the trace. Let me zoom in a little bit. So this is PLC trace. Okay, so let's measure time it takes from positive edge push button start to relay input feedback. This is additionally what I done additional signal, relay input, relay output, and basically push button. So with this mechanical Omron relay, it takes 8 milliseconds for the signal to arrive to input, and it takes around 10 milliseconds to actually get relay output signal. So from push button preset to relay feedback, it takes around 19.4 milliseconds. Now this is kind of strange because right now I'm checking when push button is 0, and as you can see, output is also 0 after 10 milliseconds, but actually I have still a signal from relay input. I don't know what's going on here. I think the logic of PLC is quite fast, and if the logic sees somehow that input is off, turn off the output. But yeah, this is strange. I don't know how to actually comment on this. And right now I go to device configuration. I go to, well, PLC device configuration, and I go to PLC input configuration. We need to go to offline to change them. And as you can see, they have these filters, 6.4 millisecond filters, meaning if there is these, well, bounces or some sort of a signal, it will not be registered as input. I just want to try one more thing. Well, I reset the counters. And okay, I will change all three inputs to 20 microseconds. Now to actually change them, we need to download hardware configuration. So PLC will be stopped. Okay, so now changes are inside PLC, and let's monitor. I will press really quickly this push button start, and I just want to see if counters doesn't match. So as you can see, I press it push button start 42 times, but output gives signal 53 times. So these relay bounces actually can affect in a negative way logic. So right now I started trace on PLC and also pushing very fast start button just to see if I can see actually what's going on in traces. And as you can see, blue line is relay output feedback. This is where the issue starts. This is the bounces. So on scope, on oscilloscope, we can clearly see there actually are more bounces, but even with this Siemens trace function, we also see, and with counters doesn't match up. So it could be a problem if you're using 20 microsecond filters, but actually it kinda is not an issue, because by default these inputs are set to 6.4 milliseconds. So yeah, but this is also strange because output feedback is 0, but we still have input feedback from relay. Input feedback, I'm talking about A1, A2 contacts on relay to energize it. And right now I change it this Omron mechanical relay to solid state relay, and I pushing start button really fast, as fast as possible. And yes, still push button counter and output feedback counter doesn't correspond. Obviously we have 95 push button inputs counted and only 89 feedbacks from relay output. Now I want to see the trace on PLC. Again, I will push very hard as fast as possible push button. Yeah, start button. Basically push button start is a red line and relay output is blue one, input is green one. So it's way cleaner with SSD relay, but still need to use filters. You know, with default value is 6.4 milliseconds, and using SSD relays you will have very clean signal, very fast signal. So yeah, not much else to say, except right now I'm zooming in Siemens PLC trace, and we can see where exactly more push button signals are counted. As you can see, top red line. Okay, I'm really zooming in, just took random push button graphic. I just want to see how much time it needs this SSD solid state relay to be triggered on. So we have edge push button going to one state, and relay output comes after only 2 milliseconds. So yeah, it's very fast. And regarding SSD solid state relay, push button is 0, then signal feedback from relay input is 0 after 3 milliseconds. And then output feedback also after 3 milliseconds. So altogether 6 milliseconds after PLC sees that push button is in 0 state, is not activated. For solid state relay, it takes 6 milliseconds to give feedback back to PLC. And right now I'm just want to mess around. Okay, I'm changing to 20 microseconds again. Yeah, I just wanted to additionally to make sure that I'm reading this correctly. So I will do that experiment one more time. I'm resetting count up counter. And again I'm pressing really fast this start push button. And right now count up and relay output counters are matching. So yeah, this is also weird. I don't know what happened. I changed it specifically. I download hardware that changes all 3 inputs to 20 microseconds and counters are in match. So maybe I pressed this push button a little bit slower than that time. So right now I'm increasing delay time for inputs. Basically just a filter for inputs, and I want to also try with that. So obviously with higher filter, longer time, it will be more better results, but this time even with 20 microseconds with solid state relay, as you can see, counter is matched. So again I'm pressing this start push button as fast as I can, and input and output corresponds. Basically, yeah, I did just a few even more tests. With solid state relay, I don't have any problem. So at the end of the day, I made some changes to PLC, so inputs have ability to delay signals coming to them. So it all depends on what kind of settings you have on PLC. By default it's like 6.4 I think milliseconds. So these relay bounces don't really affect the PLC. But if you have a really bad relay, yeah, it could affect. So I tried one throw relay, double throw relay. They all have the same, well, quote unquote issue. SSD relay gives really clean signal, and yeah, just an experiment, not actually an issue. So yeah, write in comments on what do you think about it.